Hello, this is Angelica Rahman. My ID is 211101347. So as you can see, here is a simple line following robot. This robot is same as we used in our previous project. So first let's go to the robot file, and under children part here we add a camera to the robot, then we add some distance sensors here, and we add 4 hinge joint to the robot, and we build a robot body and give the robot body shape as rectangular. Here under hinge joint and under device we gave a name to the rotational motor, and this naming part is very important because we have to remember this name as we will add this name in our code later. And also we have to make sure for each hinge joint the names are unique and different. So let's go to the distance sensors part, but first let's just zoom it. So here is our 5 distance sensor. So the translation value for every distance sensor will be different because of the position of the distance sensor. Now come to the first 2 distance sensor. This one and this one are used for object avoidance. And here we have to be assured the rays of for these 2 distance sensor are pointing forward so that the robot can detect any object and avoid it. Now, in order to follow the line, we have added 3 IR distance sensor here. This one, and this one, and we have to be assured the rays are pointing downward so that the robot can see the line under it and follow it accordingly. Now, for each distance sensor, the naming part are very important because we have to remember this name because the same name will be used in our code later.
Assalamu alaikum. My name is Tasina Shiva and my ID is 1911668. Today I'm going to show you how I create the track of our robot. So first we have to go to the website Autodesk Tinkercad. Here I will be creating a new design. So we'll use the scribble, and according to the requirements we will keep at least three left turns and 3 right turns. So here, and it's done, and then we make the height 0, and I'm gonna choose a different color here. Okay, then I'm going to export it as OPG format. Okay, so now we're going to import the 3D model in our Webots environment. I'm going to choose this file here. Okay, so it is imported successfully, and now we will have to place the track on top of the floor. To see it, we have to change the translation. Okay, so I'm going to change here. Then we have to change the rotation. And lastly, we have to change the scaling. You see, it is getting visible. Okay, so we have to place it in the plane and adjust the robot in the track.
Assalamu alaikum, I'm Afran Taranjim and I'll be showing how our PID implemented line follow robot is working and the code. So at first I will run our project to show how this is working. So we can see that the robot is changing its direction whenever required to follow the line, and it's adjusting itself to follow the line. So we have also added another feature which is object avoidance. So whenever our robot comes across an object, it will avoid collision by changing its direction and start following the ride in opposite direction. So let's look at the code. At first we have imported robot from controller, then we have defined a function called clamp to set the values within a range. Then time step is set to 32, maximum speed 3.5, and base speed is set to 3. We have added the robot, we have enabled the camera, we have added distance sensor for obstacle avoidance, we have added IR sensor for the robot to follow the line. We have added the 4 wheels and set the position of our of wheels to infinity so the robot can move to infinity. We have set velocity for the wheels to 0. Then we have added set the values for KP, KI and KD as 20, 2.5 and 15 respectively, the value, and set the values for PID and last year as 0. Then we put our robot in a while loop. loop, so it can run till we stop running. Then we have set the motor speed to 0, and we have taken the values for right, middle, and left IR sensor, and the position value is calculated by adding right IR and middle IR value, and then error is calculated at first by adding left IR and middle IR value and then subtracting from position. Then P is equals to error, I equals to the clamp value of I plus error, and D equals to the clamp value of error minus last error, and last error is set to error. Motor equals to P times Kp plus I times Ki plus D times Kd, and this value is also clamped. So if motor speed is less than minus maximum speed, motor speed equals to maximum speed, and if motor speed is greater than maximum speed, then motor speed equals minus maximum speed, and motor speed is set to 0 if nothing happens. So this is to change the direction whenever our robot is getting out of the line and bring it back to the line. Left speed equals base speed plus motor speed, and right speed equals base speed minus motor speed. Then we have added our code for obstacle avoidance. If there is no obstacle to avoid, then our robot will continue moving forward. So if left speed is greater or right speed is greater than maximum speed, then they are set to maximum speed, and if left speed or right speed is less than 0, they are set to 0. And finally the left wheels get the left speed and right wheels get the right speed. So this is how our robot is successfully being able to avoid the obstacles and follow the line using PID. So that was our project. I hope you all liked it. Thank you.